All right, let's talk about something really cool today. We're diving into a new way of thinking about AI called recursive language models. It's a clever strategy that tackles one of the biggest and honestly weirdest problems in AI right now, why they can't seem to read a long book. Let's get into it.
You've got to admit, it's a strange paradox, right? We have these incredibly powerful AI models like GPT-5 that can do amazing things, write code, create unbelievable art. But if you ask one to read a whole novel or maybe a really long, dense report and just tell you what it's about, it completely falls apart. It gets lost. So what's actually going on here?
To really get to the bottom of this, we need to talk about something called AI's big memory problem. It's this fundamental bottleneck that's been holding things back for a while.
It really just boils down to this simple question. I mean, if these things are so smart, why does their brain seem to break when you give them a lot of information at once? It's kind of like talking to a genius who forgets the beginning of your sentence by the time you get to the end.
Well, this problem actually has a name: context rot. And this graph says it all. You see, as a document gets longer and longer, the AI's performance just tanks. It gets worse and worse until wham! It basically falls off a cliff. The model literally loses the plot.
The technical name for this memory limit is the context window. But here's a better way to think about it. Imagine you have a brilliant intern, super smart. They can read the last 5 pages you gave them and recall every single detail perfectly. But by the time they get to page 50 of a big report, anything from page 1, poof, it's gone. That's the core problem we're trying to fix. And that brings us to the really clever solution in this paper. See, the idea isn't to just give the AI a bigger memory. It's about teaching it a completely new way to think.
So, here's the big insight. Instead of trying to force our brilliant intern to memorize the entire library, an impossible task, what if we just taught them how to use the library search system? What if they could look things up, pull out just the right books, read only the relevant chapters, and then piece it all together? That's the shift in thinking here. And that is what a recursive language model, or RLM, is all about. It's a strategy where the AI doesn't just passively read a text, it interacts with it. It treats the long document like a tool it can use. It writes little programs to search the document, to break it into chunks, and, this is the recursive part, it calls up a fresh copy of itself to analyze just those little chunks. Our intern just got promoted to a senior researcher who can delegate work to a whole team of assistants.
Okay, so that sounds awesome in theory. But how does it actually work? Let's take a look at the process, which basically turns the AI from a simple reader into a smart programmer.
So check this out. This is the RLM's workspace. The whole massive document isn't stuffed into the AI's memory. Instead, it's loaded into a programming environment, kind of like a huge text file. The AI can then write and run its own code to poke around in that file, search it, and slice it up however it needs to.
And the whole thing happens in a kind of 3-step dance. First, the AI interacts with the data and probes it. Then, it decomposes the big problem and calls itself. That's the recursion. And finally, it stitches all the pieces back together to synthesize one final answer. So first up, interact and probe. Instead of just reading 10 million words from start to finish, the AI gets smart. It writes a little piece of code, maybe a quick search query, to find every single mention of a specific character's name, for instance. It intelligently filters the huge document down to just the juicy, relevant parts.
And this is where the magic happens. Decompose and recurse. For each of those little relevant snippets it found, the AI basically spawns a new, fresh version of itself and says, "Hey you, your only job is to analyze this one little paragraph and tell me what it means." It delegates the huge, impossible problem into a bunch of small, easy ones that fit perfectly inside its short-term memory.
And last but not least, stitch and synthesize. The AI takes all those little answers it got back from its team of delegates and writes more code to put them all together. It's like programmatically assembling a puzzle, building one big, comprehensive answer from all the evidence it gathered across the entire document.
Okay, it is a brilliant theory, for sure. But the big question is always the same, right? Does it actually work? Well, let's look at the results.
Oh yeah, it works. The difference is just, it's night and day. On the left, you see the regular GPT-5 hitting that context rot wall we talked about. Its performance just falls off a cliff. But on the right, the RLM version, it just sails right past that limit, staying super accurate on documents that are way, way longer. It's a total game changer.
And if you look at the hard numbers, it gets even crazier. For understanding a complex piece of code, the old model scores a 24. The RLM gets a 62. Okay, now look at question answering over a bunch of documents. The base model gets a literal 0. It just can't do it. The RLM? It scores over 91. These aren't small improvements. They are massive leaps in what the AI can do.
And here is the absolute kicker. This is the part that kind of blew my mind. You'd think this smarter, more complicated process would have to be more expensive, right? Wrong. This chart shows that, for a typical task, the RLM method can actually be cheaper than trying to brute force the whole document into the old model. It's better and more efficient.
So, what does this all mean? What does the future actually look like when our AI can finally read the whole book?
Well, the possibilities this opens up are just huge. We're talking about an AI that could analyze every single document in a massive legal case in just minutes, or an AI that could read an entire software company's codebase and find hidden bugs. You could have it do a deep thematic analysis across all 7 Harry Potter books. This just unlocks a whole new universe of problems that AI can help us solve.
And it all comes back to this quote from the researchers themselves, which I think just perfectly captures this whole idea. The long document isn't the information to be memorized. It's the world for the AI to explore. That is a really profound shift in how we build these things.
Which leaves us with one final and pretty exciting question to chew on. Now that this huge barrier is starting to crumble, now that AI is getting the ability to understand these vast amounts of information, what's the first big question we should ask it?